Hi all, welcome to Go Classes daily practice questions of discrete mathematics. In this session we are going to solve a standard question from predicate logic. This question is taken from Stanford University. So let's see this question. The question is saying that consider the following diagram. A graph is given to you. You can see this graph. Now the question is saying that if there is an arrow from person X to person Y, then it means that person X loves person Y. We denote this by this predicate loves X comma Y. So loves X comma Y, this means X loves Y. So in this question we are saying that if there is arrow from X to Y, if there is arrow, then it means X loves Y. For example, you can see in this graph, you can see there is arrow from P4 to P3. So I can say P4 loves P3. But you can notice there is no arrow from P3 to P4. There is no arrow. So it means P3 does not love P4. So the question is saying that, for example, loves P4 P3 means P4 loves P3. Why? Because there is arrow from P4 to P3. So P4 loves P3. Also loves P5 P5 means P5 loves P5 because there is arrow from P5 to P5. It means P5 loves P5. Next, you can notice but not loves P4 P1 because you can see there is no arrow from P4 to P1. So it means P4 does not love P1. Now the question is saying that there is no implied arrows, means these are the arrows that are given to you and there is no other implied arrow. What it means? It means that P1 loves P3. This is, you can see there is arrow from P1 to P3. So this arrow you have, it means P1 loves P3. But you can see that P3 loves P2. Yes, because there is arrow from P3 to P2. So P3 also loves P2. But you can see the statement P loves P1 P2 is false. What this means? Because you can see there is no arrow from P1 to P2. From P1 to P2 you can see there is no arrow. There is no arrow between from P1 to P2. So I can say loves P1 P2, that is false because P1 does not love P2. So I can say loves P1 P2, that is false because there is no arrow from P1 to P2. Similarly, even though P4 loves P3, you can see because there is arrow from P4 to P3. So it means P4 loves P3. But you can notice loves P3 P4, that is false. Why? Because there is no arrow from P3 to P4. So it means loves P3 P4, that is false because P3 does not love P4. Okay, so there is no arrow from P3 to P4. It means this loves P3 P4. What it means? It means P3 loves P4, that is false because P3 does not love P4 because there is no arrow from P3 to P4. So this is the question. I hope you understood the question. Now the question is saying that below is a series of first order logic statements. So some first order logic statements are given to you. So you have to tell us which of them are true, which of them are false. So some first order logic statements are given to you. These are the first order logic statements. These are also given. Total 16 statements are given to you. Now you have to find out which are true, which are false. Also remember, if something is false, if a statement is false, you can see for each false statement, you have to tell the smallest collection of arrows that need to be added to make it true, to make that statement true. Okay, so the question is saying if a statement is false, for example, you can notice this statement. Look at this statement, loves P3 P4. This statement is false because P3 does not love P4. You can see loves P3 P4. What it means? It means P3 loves P4. That is false because P3 does not love P4 because there is no arrow from P3 to P4. So I can say this loves P3 P4. This statement is false. So what you need to do? For each false statement, you need to tell us what is the smallest number of arrows that you need to add in the diagram so that that statement becomes true. So here I can say, if you want to make this statement true, then what you need to do? Very simple, one arrow you need to add. In this diagram, this arrow you need to add. So I can simply say that for each false statement, you need to tell us how many minimum number of arrows you need to add in the diagram to make that statement true. For example, if you want to make this statement true, then you need to add one additional arrow. One arrow you need to add from P3 to P4. From P3 to P4 you need to add this arrow. Okay, this arrow you need to add if you want to make this statement true. So this is what the question is saying. So I hope this is clear to you. So a series of first order logic statements are given to you. So these statements, also these statements, total 16 statements are there. You need to find out which of them are true, which of them are false. And if a statement is false, see, if a statement is true, you simply say that it is true. But if a statement is false, then what you need to do? You need to make it true. And to make it true, you need to add some additional arrows in the diagram. You need to make some additional love relations. Okay, so very simple. So this is the point. So for each false statement, you make it true by adding minimum number of arrows in this diagram so that this false statement becomes true. Okay, and you have to answer what is the minimum number of arrows you need to add and from where to where. So I hope this question is very clear to everyone. So this diagram is given to you. You can see this diagram on your screen. Okay, so you just try this question. Now let me make sure that you understand this question. So let me tell you that in this question, first of all, the domain contains total 6 elements. So let me tell you that in the domain you have total 6 elements. There is P1, there is P2, P3, P4, P5, P6. So there are 6 elements in the domain. So the domain is finite. In the domain you have total 6 elements, P1 to P6. These are the elements. Now on this domain you are defining a predicate. This predicate you are defining. You are saying that loves x comma y. This predicate you are defining, and this predicate means x loves y. Now the question is saying that if there is arrow from x to y, that means x loves y. Okay, so the question is saying that if, for example, I can say if A loves B, then how we show this in the diagram? If A loves B, then it simply means we write like this. We create the diagram like this, that A loves B. So if A loves B, it simply means that loves A comma B is true. So I can say if this is true, if loves A comma B, this is true, then what we do? We create this type of diagram, we create that A loves B. And also remember, if you have this type of diagram, that there is arrow from A to B, then what it means? It means that A loves B. It simply means that A loves B. I hope this point is clear to everyone. So for example, if you have this type of situation, if you have this type of diagram, if you have this type of arrow from A to A, that simply means that A loves A. And if there is no arrow from A to B, for example, let's assume there is arrow from B to A, but there is no arrow from A to B, it simply means that B loves A because there is arrow from B to A. So it simply means that B loves A. But remember, because there is no arrow from A to B, it simply means that A does not love B. A does not love B. So this is what this diagram means. I hope this point is clear. So remember, in this question the domain has 6 elements, P1 to P6, and this predicate is given to you. This is x loves y. Loves x comma y, it means x loves y. Okay, and remember, this love, this is not symmetric, because you can notice, for example, P4 loves P3, but P3 does not love P4. There is arrow from P4 to P3, so it simply means that P4 loves P3. You can see there is arrow from P4 to P3, there is arrow. What it simply means? It simply means that loves P4 P3, that is true, means P4 loves P3. But you can notice there is no arrow from P3 to P4. From P3 to P4, you can see there is no arrow. So it simply means what? It simply means that P3 does not love P4, or I can say loves P3 P4, that is false, because P3 does not love P4. So I hope this question is clear to everyone. You can see P5 loves P5. You can notice P6 does not love anyone. P6 does not love anyone. P6 does not love itself also. So you can see, for example, in this question, you can see that this P6 does not love anyone. For example, if you ask P6 loves P6, that is also false. P6 loves P6, that is also false, because you can notice there is no arrow from P6 to P6, but there is arrow from P5 to P5. So it means P5 loves P5. So I hope this question is clear to everyone. Okay, so now what you do? Very simple. This diagram, this graph representation is given to you. Basically this graph, you can notice this graph. This is interpretation of this predicate loves x loves x comma y. Okay, so remember this graph, this is interpretation of the predicate. This graph is telling you who loves whom. From this graph you can notice P1 loves P1, P2 does not love P2. You can notice P2 does not love P3. You can notice P2 does not love anyone. You can notice P6 does not love anyone. P5 loves P5. P4 loves P3. P4 does not love P4. So very simple. Now what you need to do, for all these first order logic expressions, you need to tell us which of them are true. And if any of them is false, for example this is false, then you need to tell us how many minimum arrow you need to add in this diagram to make it true. For example, if you want to make it true, then you will add this arrow. Similarly, you can notice, for example, let's see this one. You can see is this true? Yes, this is definitely true, because you can notice this loves P1, P2. This itself is false. False implies anything that is true. So this 6, 1, this is a true. I hope this question is clear. So these are some more expressions that are given to you. You need to tell us which of them are true, and if any of them is false, then you need to make it true. For example, let's assume this is false. Then you need to find out how many minimum arrows you need to add in this diagram so that this becomes true. Minimum number of arrow you need to find out. What is the minimum number of arrow I need to add in this diagram so that this expression becomes true? So this is the question. So try this question, and the detailed answer is available in the description. So first you try this question, write your answer in the comments, and then you can watch the detailed video solution that is available in the description.